Once we've looked at multiplication of complex numbers, the last thing then to look at is division of a complex number. Okay, so again we'll start with an example that will say z equals 2 plus 3j, all to be divided by 3 minus j4. So how do we do this? Well, we actually don't really divide. We end up multiplying. And we've got to introduce a new term called the complex conjugate. And what the complex conjugate does, it allows us to get a real number on the bottom here so that we can then split off into a real term and into an imaginary term. Now the complex conjugate, okay, we'll make a little side note up here, and maybe we'll do it in a different color pen. So it's called the complex conjugate is when we have a complex number. Okay, so let's say what we have 3 minus j4. The complex conjugate of that is the same numbers, but we change the sign of the imaginary part. So there's a sign change there between the two imaginary, the two, I don't know, pen's faulty a wee bit there, and we're just going to have to leave that part out if it will let us. So there's a sign change going on there. So well, let's apply that, okay, and see what happens. So we'll go back to our color pen here, and we'll say, okay, so if we take 2 plus j3 in the top, and 3 minus j4 in the bottom, and we multiply that by the complex conjugate of the denominator, so the bottom, we'll get 3 plus j4 over 3 plus j4. So multiplying the top and the bottom by the complex conjugate, because this whole thing here ultimately just equals 1. So we're not changing anything to the question. So then that's going to leave us with 2 plus j3 multiplied by 3 plus j4 on the top, and we're going to have 3 minus j4 on the bottom and 3 plus j4 on the bottom. So we expand them brackets out again the normal way we would, to first, to furthest, to nearest terms, and then j, and the two last terms, 12, and we do the same to the bottom, to first, 9, to first, to furthest, to nearest, and to last. And let's see what happens here. Now these two cancel out. Okay, we can write them a little bit neater on the top. 6 plus j17 plus j squared 12. And we get 9 minus j squared 16. Again, these j squared should be ringing a bell. So you get 6 plus j to the 17. We know j squared equals minus 1 times 12. Again, on the bottom, 9 16. And rushing a wee bit here for time, will ultimately be left with minus 6 plus j17 all over 25, which we can then break out into minus 6 over 25 plus 17 over 25 by j. One real, one imaginary term.